Today I want to talk about hypothesis testing using the t-test. And we've done hypothesis testing previously using the normal distribution and Z procedures. Today we're going to do t-test, and I'm going to point out as we go through the similarities and the differences. So first of all, let's talk about the requirements for when I can use the t-test. So first of all, my variable that I am measuring has to be quantitative. Now remember from the very first part of the class, that means that my variable must have a numerical value. And in my example today, it does. Then we must know mu, but sigma will not be known. Now, remember from the Z procedures, we knew both mu and sigma. Also remember that mu and sigma are population parameters. Mu is the population mean, and sigma is the population standard deviation. When we talked about the Z procedures, we made the statement they were really unrealistic in their application to real-world problems because we very seldom knew sigma. Well, now we don't need to know sigma. So if I know mu, but I do not know sigma, I can use the t-test for my hypothesis testing. Next, we have to be sure that the random sample that we are dealing with for our hypothesis testing is representative of the population. That means that when I pick my random sample, I am not introducing any bias, and that the sample that I pick is representative of what I would find if I were using the entire population. There are also some restrictions on our sample size. If the sample is less than 15, we must have a normally distributed sample. And to verify that, what we would do would be either a stem plot or a histogram. So if my sample size is less than 15, it has to show that normal curve that we're all familiar with. If my sample size is at least 15, I can use the t-test if my data is not normally distributed, but I cannot have any outliers. And again, we would be able to see this from a stem plot or from a histogram. Last, if my sample size is greater than 40, I can use the t-test even if my sample data is skewed. So if I plot my histogram or I do my stem plot and it turns out that my data, my sample data, is either right or left skewed, I can still use the t-test provided my sample size is bigger than 40. Now let's talk about the steps that we would use in hypothesis testing in general and the t-test in particular. So the first thing that we would do in the case of the t-test would be to verify that it actually could be used. And once we have verified that, we would state the hypotheses and identify the claim. And I'll go into some detail on that in a few minutes. Once we have done that, we would actually compute the test statistic. Now, back when we were talking about the normal distribution, the test statistic was a z-value. Now that we're doing a t-test, my test statistic is actually going to be a t-statistic. And the way that we compute those is actually different. Once we have done our test statistic, we would find the p-value. and the p-value tells me the probability that we would get sample data like what I have, and it would be this representative of the data given that the null hypothesis is true. So we're measuring how likely I am to get this set of sample data if the null hypothesis is true. Once we've done the p-value, we would make our rejection decision. We would either reject the null hypothesis or we would fail to reject the null hypothesis. When we're doing our rejection decision, we don't really ever say that we accept the alternate hypothesis. We just either reject the null or we fail to reject the null. And once we have done that, we will state the conclusion. So let's take an example. Now, my example is the manufacturer claims that the average calorie count for a 1 ounce chocolate chip cookie is 110 calories. As a researcher, I do not believe this. I think that it's actually more than that. And so I'm going to do a hypothesis test to either prove that the manufacturer is correct or disprove it. So what I did was I went out and I selected a sample of 15 different brands of chocolate chip cookies. And I calculated the number of calories in each one of these 15 brands. Now, I am selecting an alpha level of 0.01. So remember, our alpha level is my willingness to have a type 1 error, which means that I am rejecting the null hypothesis when it's actually true. Now, with a 0.01 level for my alpha, I'm not willing to make that mistake. If I were a little bit more willing to be wrong in that respect, I would select an alpha level of 0.05 or a 0.10. So at the 0.01 level, my question is there sufficient evidence that the average content of the calories is greater than 110 calories? So that's my claim. Now, here are the sample data that I collected. And one thing that you will notice is that the calorie content goes from 100 calories all the way up to 185 calories. So we're going to go through the steps that I listed earlier for hypothesis testing. And the first one was to check and see if I could even use the t-test. So first of all, my chocolate chip calorie count is a quantitative variable. In this case, it's 110 calories, or my sample data from 100 to 185 calories. So that is a numerical value. It is quantitative. I did not in any way select only high-end chocolate chip cookies that might have used butter and lots of sugar in the cookie and therefore has a bias towards a high calorie content. I went out and I picked a sample of cookies that's representative of all of the chocolate chip cookies. So I have a representative sample. Now, since my sample size is actually equal to 15, I can only use the t-test if I have no outliers. So remember I discussed earlier, we would either look at a histogram or a stem plot to verify that. Well, I did do a histogram from StatDisk, and I'll show you that in just a few minutes. And it does show that the data is slightly left skewed, but there are no outliers. Therefore, based on that, I can use the t-test. So here is my histogram. So if you look at it, It does look like I have a little bit of a tail going off to the left, so it is slightly skewed, but again, there are no outliers. So I'm good to go on my t-test. Now, next thing I want to do is to state the hypotheses. Now, remember the null hypothesis is the status quo. That is the claimed value, in this case by the manufacturer of the chocolate chip cookies. It's a value that is accepted by the public as being true. And in this case, the mean, mu, is 110 calories. That is the null hypothesis, that the mean number of calories in chocolate chip cookies is 110. The alternate hypothesis is often called the researcher's conclusion. This is what the researcher believes to be true and is therefore trying to prove with the hypothesis test. And in this case, I am contending that the mean number of calories in the chocolate chip cookie is more than 110 calories. So that is my alternate hypothesis. Now, in step number 2, we're going to compute our test statistic. Now, I entered the data, my sample data, into StatDisk in order to be able to do my histogram. So it's already in column 1 of StatDisk. Now, the next thing that I'm going to need to do before I can actually do the hypothesis testing is I'm going to need to get the mean and the standard deviation for my sample data. So what we do is we select from StatDisk at the top of the menu, data, then descriptive data. And we would select our column 1 where our data existed, and we would find that the mean for the sample data is 137.333, and the standard deviation for our sample data is 24.1178. So I would write that down, and I'll need to use it in my next step. So now we're actually going to do the hypothesis test in StatDisk. So again, at the top of the menu, I would select Analysis. Then I would select Hypothesis Test, Mean 1 Sample. And what happens at that point is that you get a little pop-up, and it asks you to enter in some information. So the first thing it asks for is the level of significance, and that was 0.01. That was what I chose for my level of significance. It would ask for the claimed mean, and that's what is always in the null hypothesis. So that, in my case, is 110. It would ask for the sample size, which is 15, and then it would ask for the sample mean and the sample standard deviation, which I did in the previous step. So I would enter those values in, and I would click Evaluate. Now, we get a pop-up that comes to our disk and to our computer that looks like this. First of all, the claim is mu is equal to mu, because that is what I am claiming in my null hypothesis. You'll notice that the test statistic is 4.3893. You will notice that the p-value is 0.0006, which is quite small. You will also notice a 99% confidence interval. Now, we talked about confidence intervals back when we were doing the Z procedures. And this means that I am 99% confident that the population mean would be between roughly 119 calories and 156 calories. Then we are also told to reject the null hypothesis, because the sample provides evidence to reject the claim. Now, the thing to remember here is the claim is always your null hypothesis. So now we're down to step 3, which is find the p-value. Now, that was given to us on our output from StatDisk, and the p-value was 0.0006. So now we're going to use that in our decision to reject the null hypothesis or not. So that's step number 4. Make the rejection decision and state the conclusion. Since the p-value, which is the probability of this sample occurring if the null hypothesis is true, is less than alpha, which we chose was 0.01, then the null hypothesis is rejected and the results are said to be significant. Now, my conclusion is that the data supports the rejection of the null hypothesis, that the mean number of calories in a chocolate chip cookie is 110, and it supports my claim that there are more than 110 calories in the chocolate chip cookies.